Hello, just getting the iPad finished and we'll be good to go.
No, we had a game when there was a ton of games.
They get admitted or no?
No, Miss Danny.
Yes.
Today the first day of Mardi Gras.
Oh yeah, New Orleans. They start celebrating a little ahead of actual Wednesday, actual Tuesday.
Hello.
What's happening?
Hello.
Fire travel is connected.
Oh, they don't do that to me.
Oh, yes.
How did you lose my science, stupid? Whatever. Give me later. No. You know better.
Miss Danny.
Yeah, hang on a sec. I'm coming. I'm getting the iPad going, or trying to.
Oh,
But it doesn't
he
want to.
doesn't want to let the ball go.
No, that's his ball. That's his, yeah, that's what I thought.
I'm not doing that for my ball. What I'm really saying, I'm not doing it.
Gotta take your mask off.
Nope.
It was the weakest.
Bro, try it. I guess it's not red.
Make a color. Okay, let's see. You are torturing me.
That was good enough.
Poor dog.
Yeah, if he does it too hard, then it's gonna stop.
You don't make him.
Got that twice. It was rolling
Make
out.
sure that's actually centered. Hello, Jocelyn. Good morning.
Good morning. I got up at like 8 o'clock this morning.
There we go.
And then watched Rapunzel while eating a stick donut from Dunkin' Donuts that we got last Sunday.
All right, let's get everybody in. Senya's in here too.
It's snowing for like the 3rd time in a row.
It's snowing for the 3rd time in a row. Are you serious?
It's no.
Yeah.
We had a tiny bit of snow here, but I missed it because I was out of town this. Oh my gosh, look at Jocelyn's yard, you guys. Connecticut. Yeah, no, that's gorgeous.
And we're supposed to be getting more snow today.
That's wild. How pretty is
It's already like ankle deep to me. It's like right here.
Whoa. We don't get that here, man.
And then we also have a mound of snow that our plow guy pulled up, and now it's going to be taller. We call it Mount Everest because it's humongous. Now it's going to get taller because it's snowing again.
I got to turn my lap.
Just
Eleanor, this is you?
Whoa.
Alex. I
forgot to bring
Good for you.
But I did do the lab. I just forgot to turn it in.
Yes, true. Is it what? Illinois? Yeah. Okay, so let's see, guys. So we had, did you guys have a good weekend? Everybody had a good weekend?
my mom's birthday was this Saturday.
Your mama's birthday. Please give her a birthday hug for me. Tell her I love her.
Well, it was last Saturday.
Oh, last Saturday. Okay. She's the best. Your mama's a sweetie. All right. Let me get. So this weekend, all right, are we good? Got everybody? We're all good?
Yep.
Good. Okay. So this weekend, I was actually out of town. I went to Chattanooga. Have you been to Chattanooga?
Yeah.
No.
Chattanooga is like a geologist's dream, right? Tennessee, just inside Tennessee. So we went because I got Jason a hang gliding trip for Christmas. So he was 2,000 feet up in the air with a little piece of canvas above his head and some other big dude hanging below him. But I know, but there are caves all over Chattanooga and like all kinds of crazy stuff. It was really pretty. It was really pretty. Oh, it's on the bar. So Senya is with us this morning, but she has a doctor's appointment, so she's on mute. So we won't hear her, but she's there. And does anybody know where Sky is? Anybody heard from Sky? No, maybe her mom sent me something this morning and I just didn't see it yet. So let's see what our lesson is. Oh, and you guys got to see a little snow. We got to see snow too, but we were on top of a mountain. We saw the snow. Pretty cool.
I get to be in the comfort of my warm home watching snow.
This is true. She has gorgeous snow right there in Connecticut. All right, so
Which, I mean, it's not half bad, but at the same time, can you at least let some of the snow melt? Like up to my knee and up to Kathleen's waist, and I'll have to carry her around.
can you imagine that? Having her little sister has snow up to her waist, she's had to carry her through it.
Well, I mean, she's small, so.
I know, but man,
I'm also taller than my mom, like an inch or two.
well, that's not hard to do. Your mama's a shorty. Ah, she is. I can say that because I'm a shorty. It's okay.
I'll tell her you said that.
It's all fair. All right, gang. So Jules, you with me? Alec, you with me? All right. So if you were here last year, you've probably seen some of this because we ended last year's physical science class with a little bit of chemistry, and we started with some acids, bases, and solutions. So what we're doing today is we're going over that again, but this time from the chemistry perspective. So acids, bases, and solutions. This is kind of getting towards the end of our chemistry. We are in the second half of the third quarter, which means that once we get to our fourth quarter, we're going to start moving into some more of the organic or biological chemistry, which is going to lead us right into biology next year. I know some of you will definitely be back. Some of you are still deciding, but it should be super duper fun next year. So properties of solutions, we talked about this a little bit, and these are, you should be able to see some of this in your notes as we go along. Some of these will look like answers that you have or similar answers. Okay, so solutions are a homogeneous mixture, right? So what does that mean? Do you remember what that means? The homogeneous versus heterogeneous? Yep, all the particles are about the same size, right? So you can't separate it. Anybody want to give me an example of a heterogeneous mixture? Jocelyn's thinking.
I forget which,
Heterogeneous mixture. Think
I
about it.
forget which one is which.
So the heterogeneous is the one where you can see all the different, you can most of the time see with your eyes even, all the different sizes of particles, different kinds of particles.
A salad.
A salad. That's
Or
a
a
good
fruit
example.
salad.
A salad. Okay. Who likes a good salad?
Or sand.
Sand is good too. I love a
I
good
like salad without dressing.
Oh, do you?
Last
That's
time I
a
had salad,
really good salad.
I had to have like 50 croutons, 60 black olives, and a piece of raisin swirl bread to eat it. Because I don't know why. I just hate salad with dressing.
Now, Jocelyn has a good point. Who likes black olives? Anybody? Oh, really? Okay, wow. All right. All the girls.
That could be my one meal for a whole day. They're so
Mine-
good.
I don't mind black olives, but I'm more of a green olive type.
Oh, I like olives with like the carrots in them.
Oh, the pimentos in the middle, that's a pepper in there. It's good. Yeah. So I had a salad yesterday for lunch, or not yesterday. Yeah, was it yesterday? No, yesterday. No, day before yesterday in Chattanooga before we left. And it was an interesting salad because it was a great heterogeneous mixture. It had the lettuce, right? But it had like 2 or 3 different kinds of lettuce. And then it had corn and beets and roasted tomatoes and asparagus chopped up really small, which you usually don't see.
What day? Is today like February 1?
Today's the 9th.
How many days?
28. I'm itchy, sorry. So anyway, I had a great heterogeneous salad there, but I also had a homogeneous drink. I had a soda. It was a good solution. It had some sugar dissolved in some carbonated water, which had carbon, right? The water has carbon dioxide dissolved in it. And then the water also had sugar dissolved in it. So it was quite delicious. So a solution is composed of one phase, like a solid, liquid, or a gas, and particles in a solution are not visible to the naked eye. So remember, you can have solutions that are gases. That's hard to remember. Usually we think of solutions as liquids, but they're not always. And sometimes they're solids too. And a solution does not scatter a light beam. Okay, this is actually called the Tyndall effect. And if you take a, say you have a beaker of multiple solutions and you're not sure if they're actually solutions or if maybe one of them is a mixture, if you put a light to it and it doesn't refract, you've got a solution. But if you put a light to it and suddenly like the beaker and the contents light up instead of the light going through it, then you have got yourself a mixture. It's a good way to tell. There's a good picture of it in the lab rat slideshow. I'll see if I can find it for you before we get to it. And the components of a solution cannot be separated using a simple mechanical filtration. So in lab today, we're going to make a saturated solution. And what we're going to do is we're going to actually separate out any solid that won't dissolve in the solution, because the solution itself can't be separated. The only thing that would be separated is the stuff that can't get mixed in because there's already so much, right? So what is dissolved and what does the dissolving? You guys tell me. What's dissolved?
The solvent.
The solvent does the dissolving. That's perfect. The solute is dissolved and the solvent does the dissolving. If you've ever, I don't know, we do a lot of antiques around here, which you can probably tell from some of this furniture in this house. We've done a lot of stripping, furniture stripping, and that paint stripper is a good solvent. Like it will dissolve the paint, right? It turns the paint into this slimy, gross solution. That's a great solvent. So here are some examples of solutions. So a gas solution, a good example would be air, right? And a gas liquid would be your carbon dioxide in your soda. Then a gas solid. So this is interesting. A gas solid, hydrogen gas and palladium metal. I am honestly not exactly sure what that's used for. I meant to look that up beforehand, but that's interesting that there's a hydrogen gas inside palladium metal that they can use and make a solid and gas solution. So a liquid, they're using gasoline as a solution example. And a solid liquid, sugar and water, that's very familiar, right? A liquid solid. Okay, so think about this. The solid liquid versus the liquid solid. So the solid liquid is the solid dissolved in the liquid, right? It's the sugar dissolved in the water. And then the liquid solid is, in this case, it says mercury dental amalgam. Does anybody know what that is? It's with dentists, yep.
Do they use it for something?
Yeah, they do. Okay, so if you guys, you probably, yeah, so it's not actually silver, but that's what it is. It's mercury dental amalgam. They don't use mercury anymore because mercury is really toxic.
Yeah, but they put silver too. Something I used it like this.
It's a filling. So have you ever, how many of you have had a cavity filled? I've had more than
My sister has twice.
has. So if they're doing it in your baby teeth, chances are they're going to use an amalgam, a dental amalgam that's silver in color. You ever seen silver fillings in people's mouths? Okay.
Nope.
Used to have mercury in them. We now know that mercury is not such a good thing to put in your body. It's very toxic. It's a neurotoxin. You don't want it in your nervous system. It's like now they use what's called a composite and they match your tooth color, especially if it's a grown up to permanent tooth or if it's something that can be seen in the front, like on the lower teeth, they'll do a lot of white fillings, the composite ones. And then they'll do the mercury, I mean, not mercury, but the amalgam fillings on the top because, you know, when you open your mouth and talk, nobody really sees the surface of your upper molars, right? But sometimes people can see the surface of your lower molars. Yes, Eleanor?
Did you know that back in the really, really old days, people used to use lead plates and they would eat tomatoes on the lead plates? So they
Ooh.
and if the lead would seep,
Mhm.
like go into the tomato and they would eat the tomato and die. And they
Mhm.
always thought tomatoes were just cursed then.
Yep.
$10 says he learned that from the Outlook route.
Yeah.
Oh, there you go. Good
Yes.
call. All right.
And later in that video, he
Hooray for
said
YouTube.
that it was false.
Oh, who knows?
So
So,
he said that someone tried to kill Washington with the tomato was false. That's smart.
oh, that's funny. So yeah, so people, yeah, we've learned a lot about lead. Lead's not good to eat. And if you have, if you
Or
live in a-
stabbing your skin.
yeah, so lead is
You
toxic.
got lead poisoning.
Yeah, and so they used to use lead in paint quite frequently. So if your house is over a certain number of years old, I don't know if anybody's here has a house that old, but if your house was built before a certain year, there are chances that the paint inside, like around the windows and stuff, might have lead in it. And they worry that little babies will like chew on the window, babies chew on things, chew on the windowsill or get a paint chip in their mouth, and then that can cause problems. When I was a kid, it was a bigger deal because when I was little, there were lots of houses that were still built within that time frame. So anytime you had to buy a house, there was this whole disclosure thing that you had to sign about whether or not you had lead in your house and you were going to poison people. And then the other one they have here as an example is solid sterling silver. So you know what sterling silver is? What's in sterling silver? Do we know?
No.
So silver on its own, just AG silver, right? It's not as weak as gold, but it's a little weak. And so with sterling silver, what they do is they add a couple of other metals to it. One of the ones they add is nickel, because nickel's cheap and it's very durable. So they'll throw in some nickel and you can get sterling silver of a certain percentage nickel. So some people are allergic to nickel. I'm one of them. I'm like super duper allergic to nickel. I can't wear a lot of fun jewelry because it makes me, I get a terrible rash. It's awful. So
Expensive.
it's expensive, but if you're like me and you want jewelry that's silver, you have to either get the really high end sterling that has like less than a percentage or whatever of nickel, or you end up with like my rings are platinum because I didn't want to risk silver. But this cross here is only made by one jeweler. There's thousands of women all over the world that have this particular cross because it's from the Episcopal Church, a particular order. But it's only made by James Avery, which happens to be in Atlanta. And theirs is 99.8% nickel free. So I can get away with it. Same thing with the chain. But sterling has other metals in as a solution. Nickel's usually the one you find. All right, so acids and bases. All right, let's see. Who can answer these for me? Acids turn blue litmus paper what color? Yes,
Red.
red. And bases turn red litmus paper what color?
Blue.
Blue. All right, good. That's a good one.
Credit.
But now?
I'll give the credit. I said it first.
Oh, okay. So acids give off H plus ions in water. What do we call those H plus? Does anybody know?
No.
So those are hydrogen, right? Just hydrogen, nothing too fancy. And it's an ion, right? Because he's all by himself. He doesn't have a buddy. And what do bases give off? What's OH negative? Does anybody know that one?
Wait,
No. I am not intelligent.
So that one's hydroxide.
yes.
All right, so when you put an acid in water, it'll start to dissociate and you'll get some free floating hydrogen. If you put a base in water, it'll start to dissociate and you'll get some free floating hydroxide. Now I want you to look at those two. We have an H, an O, and an H. If you stuck them together, what would you get?
Oh,
What chemical compound would you form if you stuck that hydrogen and that hydroxide together and combined them? O and an H and an H make what? Put the H first. H, and then what would your subscript be?
oh,
You have two of them. So it would be H2.
Oh.
water.
Water. Oh, water. Yes. So here's something to know. When you put an acid and a base together, they're going to produce a couple things. They're always going to produce water and a salt. And then usually you can guess, but a salt. Yep. A salt will form. So acids generally taste what? What do you think?
Sour.
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 All right, Drew, you tell me about bases. Bases taste what?
Bitter and feel slippery.
Bitter. Okay, we're not too slippery yet, but yes, they taste bitter, right? And that's because of that hydroxide. But they may have other tastes depending on the rest of the molecule, whatever else is attached. Poor Lily, you had a busy weekend. Look at her. She's blinking to stay awake. You all
I
right?
have an audition today.
Ooh, for what?
I'm playing.
Good for you. I love that. I wish I had time for that in my life. So acids corrode what? What do they corrode? Do we know? Metal. Yeah, think about batteries. Think about your battery acid. If it leaks, doesn't it corrode?
Then it'll start rusting over.
Yeah, it corrodes all of the contacts inside whatever device you're looking at.
I remember one lab that I got in a kit, something exploded in it and it rusted over the lighter and the
Yeah.
top.
She had a great example. Unfortunately, her little bottle of hydrochloric acid, despite my doing my best to put it on tight, leaked. And it leaked inside of her lab kit that I sent her. And that acid got all over some metal objects and they all corroded. They all got rusty and nasty and they don't work very well anymore. Actually, I have her lighter down here that she sent back to me. I'll have to show it to you. It's a mess. So acids corrode metals. And what do bases do? They denature proteins. Okay, denature is a new word for you. Basically, this is the word we use. We talk about breaking down proteins themselves. There'll be more of that in biology. So bases are usually, Drew said it. Oh, wait a minute. Sorry. Let's do this one first. Acids have a pH of less than 7. And bases are usually soapy in nature. That should have gone first. And then pH is greater than 7 with a base. So we'll go back to pH in a minute. So here's how they're similar. When you dissolve an acid or a base in water, it makes blank. What? Do we know? We just saw it. Yes, Drew? It does make a salt. We talked about that. But what happens when you put the acid in, you get hydrogen. And when you put the base in, you get hydroxide. And what were those? I'll give you a hint. They make the water conduct electricity better. So they are ions, right? They either make a positive or a negative charge ion flow into that water, which is going to make it conduct electricity better. So the stronger the acid or the base, the more ions that are produced and the conductivity of the solution increases. Remember way back when we put salt in water, sugar in water and all that kind of business to see what conducted electricity? We're talking about ions. Do you remember? It was that shedding light on ions with a little light bulb. And we had the little light bulb and then we put like sugar water and see if that conducted. And then we put salt water and salt water worked better. This is why if you use distilled water, you're not going to get any kind of conductivity because it's really pure. But if you use tap water, you probably will. Because there's probably like some fluoride and goodness knows what else, chloride floating around in there that'll help. So they both conduct. And when an acid reacts with the base, what did we say? What's formed? Salt. A salt. When they react, okay, with water, you get ions, right? But if they react, you get a salt. And they both can carry and share ions. All right, so here's our game to play. Acids versus bases. We played this last year and it was interesting. So what we're gonna do is we're gonna look at each item and we're going to decide which category it's gonna fit in. Is it an acid or a base? So we'll go around, actually I'll let Alec start. So Alec, milk, where do you think it's gonna go? Don't tell him, let him guess.
Acid.
Milk, let's see. Oh, acid or base? I made that fancy thing first. Ha! Okay, yes, milk. There we go. Milk is going to be an acid. How about, I think mango is the next one. I don't remember if I went down or across now, but Drew, how about mango? What do you think?
Acid.
Let's see. Oh, wasp venom was next. So I lied. You can do bleach, Drew. So wasp venom is a base. Go figure. It really hurts if you've ever been stung. No, just go around. So Drew, how about bleach? What, acid or base?
The book, because
What do you think?
I don't like looking at stingers. Like a bee did on me once in school, and I freaked out. Like I started crying. I was running. I was like, "No, get it off of me! Get it off of me!"
I actually have an EpiPen for
Like
one.
crawling up my
Drew guessed
face.
right. Drew guessed right. Bleach is a base. All right, what do you think, Eleanor, about mango? Acid or base?
Acid.
Base. Let's see. Oh, it's an acid. Mango's an acid. Excellent.
I said acid.
You said acid. All right, Jules, how about vinegar? Acid. Good job. Ella, how about lye? Do you know what lye is? So lye, they used to use it to clean things, and it used to be in soaps and things like that. It's really, you think it's a base? Okay, let's see. That's right, it's a base. You definitely don't want to get it on your hands. It's not
Acid base, acid base.
No, it's not.
not necessarily. All right, how about apple, Lily? What do you think? Lily says apples are acids, and she is right. All right, Jocelyn. What about spinach, Jocelyn? Is spinach going to be an acid or a base? Hmm.
Cough, cough, base.
What do you think? It's 50-50. Take a guess.
A base.
A base, she says. And she's right. Anybody else get that weird? Sometimes when I eat spinach, I get that weird kind of, yeah, it's kind of got a weird feeling in your mouth. That's probably the slimy base thing. I don't know, soapy base thing. All right, Alex, so pineapple. Mm-hmm. All right, let's see. He's got it.
Acid base.
No, some of them hopped around. How about soda, Drew? Soda's an acid. This is why even if you're drinking diet soda and it has no sugar in it, it can still hurt the enamel on your teeth. It can still get your teeth because it has carbonic acid in it, which is produced when that the dissolved carbon dioxide starts to come back out of the water. Sometimes there's some interaction there.
They say no sugar, but I just have other sweeteners that are like,
Mm-hmm.
extra sugar. It's still gonna hurt your teeth.
Yeah.
You have anything sweet.
Well, the way sugar works with your teeth is it gives the bacteria in your mouth something to eat. They eat it. They produce acid. That acid hurts the enamel of your teeth.
Isn't diet actually sometimes worse?
It depends on for what, like in what, like for what problem. So how about hand soap? Base, she says, and she would be right. Soaps are often.
But it's slippery.
Yeah. What do you think about lime?
Yeah.
Lime is an acid. You got it. Good. All right, Ella, how about baking soda? Base, she's got it. Window cleaner. Ooh, what do you think, Will? Base. All right, that's a good one. So window cleaner very often has ammonia in it, and ammonia is a base. All right, how about you, Miss Jocelyn? We got stomach juice. That's such a fun word. I love that word, stomach juice.
Acid.
Acid, you got it. And then last, drain cleaner. Let's take a vote. Is drain cleaner an acid or a base? Who says it's an acid? True. Who says it's a base? I'm just space on the acid side. He says, I love the deduction. All right, yes. So drain cleaner is a base. It often has what does it have? Some form of hydroxide in it. Sodium hydroxide? No, I don't know. But yes, it's a base, and it's actually one of the stronger bases in your household cleaners. If you're looking for household cleaners,
I was gonna say it was an acid because it decomposes stuff that's clogging your drains.
It's true. Yeah, I don't know what that was. Oh, here we go. That shouldn't have been there. All right, so here we go. Common acids and bases on a pH scale. So neutral is number what on the scale? You with this, Jules, Eleanor?
Huh?
What's neutral? What number? 7. All right, so pH scale goes from 0 to 14. 7 is neutral. And here's where various things fall. Like your batteries are down here. They're super acidic. Lemon juice. Oh, here's your stomach juice. So battery, stomach juice, or stomach acid. I know. Lemon juice, wine, bananas, black coffee, milk, and then pure water. So we've gone from very acidic to less acidic. Now look at this. If you put battery acid on your hands, it would hurt your hands, right? If you left lemon juice on your hand all day, it might do some damage, especially if you went out, like people, when I was a kid, we used to put lemon juice in our hair and go out in the sun because it can help, it can actually change the color of your hair, make it lighter.
I won't be fine. Lemon
Yeah.
I gotta clean them.
But stomach acid, so stomach acid, your stomach is special in that it can manage that much exposure to a strong acid.
Dissolve anything, right? Like almost anything.
It can dissolve a lot of stuff, but it doesn't dissolve you. It doesn't dissolve your stomach.
Yeah, but it can't
right?
dissolve itself, but it's like diamond, you know?
Mm-hmm. Yeah, it can dissolve a lot. Stomach acid is really strong. It's a 1.
Pure water would be number 6, right?
No, 7 because it's neutral.
Decompose, like anything in your stomach is ridiculous. Almost anything.
Mm-hmm.
It happens over a long, extremely long period
because that's not pure water. That's water with, well, it depends. It could be pure water if your rock is something like limestone, because then it would be a base combining with the water, and that would start breaking down the base into ions, and it would leave, like, that's how you get caverns and things. But typically what happens, Drew, is like if it rains, that's pure water, but on the way down, you ever heard of acid rain? Acid rain was like a big thing in the 80s. Yeah, it was a big thing in the 80s. We were all worried about acid rain. And basically it's the idea that there is some component of pollution, different components that will cause the rain on the way down, the water on the way down, to become acidic. And then when it hits the ground, it can dissolve things.
It was hurting the forest in Germany.
Yeah, and there's always some level of acidity to rain in certain areas. And then in the past, things like volcanoes can cause the pH of the rain to change. It's in the atmosphere, right? All of those pollutants, but they're natural pollutants still. So then when we go from basic stuff, we've got blood, egg, household bleach. What does that say? Household cleaner. I think it's a household ammonia. There it is. Hair remover, oven cleaner, and drain cleaner. No, we mean hair remover, like the kind that you put on that dissolves your hair, like Nair or any of those. Yeah, they don't use them as much anymore, but huh? No. So you can get, no, it doesn't hurt. It's like a lotion. It smells terrible. Yeah. Oh, no, you mean like waxing? Yeah, that's wax. Yeah, it's terrible. But this stuff is a lotion that you put on, like say you've got dark hair on your arms and you don't want that. So you put the lotion on and then you wait a little bit and then you rub it off and all your hair goes with it. So, well, you can't really shave your arms, or sometimes ladies have facial hair that they want to dissolve rather than shave because it looks a little different. So here we go. Here, this should be in your notes. So what does acidic food taste like? We said it before, it tastes sour, right? And when found in foods, what does a base taste like? Girls, are you with me? Bitter, right? Be sure you're paying attention, okay? So compare how an acid and a base will react with the metals, magnesium, zinc, and iron. What do we have for this answer? Who's got something they want to share? Magnesium, zinc, and iron. Who's got magnesium? Nobody? Anybody? What did you get, Lily? You got something. What did you get for compare how an acid and a base will react with, say, magnesium? What did you get for magnesium? You get something? Got it, can't find it. What'd you get, Eleanor?
Acid, when these including copper, zinc, and iron react, the metal seems to disappear. They didn't react with metals or how do you say carbon?
Carbonite? Oh, okay. Found that one somewhere, huh?
But they do react with acids in a chemical reaction.
There you go. So acid is corrosive to metals, remember? So magnesium, iron, zinc, those are all metals. So it's going to wear away the metal and it's going to produce bubbles of hydrogen gas. That's what happens because it's producing hydroxide, and you will eventually see some of those little hydrogens break free and you'll get bubbles. Bases don't react with metals, but acids do. So acids are always going to cause your metal to corrode. All right, compare how an acid and base will react with carbonate. I think that's what Eleanor was saying. A base would not react, but an acid will produce carbonate ions, right? Okay. So what color does an acid turn litmus paper? Yeah?
Red.
Red. And how about a base, Ella? Blue. That's easy to remember because base is blue, right? If you just remember base, blue, you got it. So what's neutralization? Who can tell me what that is? Eleanor, what you get?
Reacting with acids in a chemical reaction.
Okay, good. Base and an acid react and they neutralize. So acids have a pH of less than 7, right? And bases have a pH of greater than 7. If they neutralize each other, what would you expect the pH to become? Should become 7 if they completely neutralize. So when you neutralize, A neutralization is a chemical reaction in which acids and bases are added together to deactivate. Basically, they take away the properties of each other and they end up, it's the whole reaction where you ever put like vinegar and baking soda together and watch it, right? If you check the pH of each before and after, and then you check it in the middle, you'll find that they totally, yes.
Let's say, what if you had something that's a pH of something, less than 7, and then you had
Mhm.
something that was the absolute, what's the absolute difference of the
Mhm.
acid and the base? Is this double?
Okay, I see what you're saying. So what if you had like a 2 and a 2 and an 8? Is that what you're saying?
Like something like that. So let's say you have less than 7, let's say you have 6, and more than 7, let's say you have 8, like
Mm-hmm.
one away from.
Yeah. So if you have, so acids and bases, depending on how weak or how strong they are, is I think what you're getting at. So say you have a weak acid and a strong base, they will not completely neutralize each other unless you add more and more and more and more of that weak acid.
What do the numbers have to be?
Think of it like a war. If there's
Well, it's not so much about, it's like one side fighting the other, like a war. It isn't so much about what do the numbers have to be, but if they were exactly opposing, like if 7 is neutral and you had a 6 and an 8, similar quantities of a 6 and an 8 should neutralize each other. But if you have a 6 and a 14, you're going to need a lot more of that 6 to neutralize that 14, if that makes sense.
The absolute difference should be, no, sorry, from the
Yeah.
7,
Mm-hmm.
the absolute difference should be like doubling out.
Kind of. It doesn't work out as evenly as it's not, the ratios aren't as beautiful as we'd love them to be, but yeah, you get the
There's
idea.
probably some, like it's not good. There's probably
Yeah.
some
I gotta put food out for him.
theoretical number that you could use. To
Might be.
calculate it, like
Yeah, might be.
like pi or something.
So what's
Not pi.
that's a really good thought, Alex. So what's corrosive mean? Anybody want to give a shot at that one? What'd you get, Eleanor?
It means they wear away other materials.
There you go. Corrosive is that substance that can wear away certain materials. Very good.
No, corrosive it just means it can corrode.
It can
And
corrode.
then you
That
start
just
the
wearing away.
definition, then
Mhm.
you go search the definition of corrode.
Right. Okay, there you go. So we'll look for take the adjective and then go back to the verb is what he's saying. But yes, that's what it means. So how about an indicator? What's an indicator?
Something that indicates the pH level?
Yeah. Ella, do you remember when we did outside? We went outside one day and I said, here are some examples that, here's some ways that you can tell that a chemical reaction has taken place. And one of the things we did was we had that little flask and somebody blew in it. I don't remember who it was. Yeah. Do you remember that it?
blew in one outside.
Yeah. Was it you, Jules? And do you remember it changed color? So that is an indicator. I've got 4 or 5 different kinds of indicators upstairs, but that's an indicator. Yeah, that's what it is. So an indicator is a substance that changes color in the presence of an acid or a base. So compare and contrast acids and bases. How are they alike and how are they different? Who has something to share? We got about 4 minutes. You don't want to share? Nobody wants to share. I need to see them to make sure everybody has an answer. Ella's showing me her answer. There it is. I see Ella's got it. Check mark for Ella. Y'all want to hold up what you got? Oh, you turned it in? Okay. You can hang on to it. He's got an answer. No, I'm getting it. All right. So then how about this? Somebody, Ella, do you want to tell us? Do you want to share? No, Ella, don't want to share. Eleanor, do you want to share yours?
No, I'm just going here.
Somebody share. Drew, you share. What's it say? What have you got? Okay, so what's your answer?
Acids are compounds with specific properties, and acids and
Carbonate. That's a good one.
Bases are compounds that, like acids, have specific properties. They do not react with metal. Taste bitter.
That's very, very good answer. Very, very thorough. That works. Excellent. So if you have not shown me your answer, so you did. You put yours up. Okay, you can keep. I think your homework actually said keep in binder. So does it say, Drew, don't lean on the table like that. Does it say keep in binder? I think it did for today. So just show it. Be sure I see it. And then I think you guys will be good. No, as long as I see that you did it and your answers, you think your answers are good? Yeah, where's the one with the, you turned it in? Okay. Yeah, you just showed it to your dog. You just showed it to me. Okay, good. So today's lab, so Jocelyn, Senya, and actually Sky too. Hang on, y'all. So today's lab, yours is online and you can watch it. Next week, fall break, no class. Hooray, fall break, no class, right? Excellent. So you guys have a nice vacation next week since I won't see you guys. And then, not fall break. Did I say fall break? Winter break. Winter break.
Winter break.
It's not fall anymore. It's winter. So we're gonna go to our lab now, and y'all be sure to look online. Sky, it's online.
Make sure you show them the letter that got corroded.
Yeah, I will show them your later. It was a mess. All right, see you guys later. Bye.